afternoon again, everyone. So today we'll be reviewing MBAL, and MBAL is a part of a larger suite of software. So I just pulled up the Petroleum Experts website, or PETEX. And if we go on PETEX and we go into IPM suite, we have some information on what MBAL and the other Petroleum Experts software is, right? So Petroleum Experts, or PETEX, developed the Integrated Production Modeling Software, or IPM. So sometimes you hear people referring to MBAL, Prosper, and GAP as PETEX or IPM. So IPM models the complete oil and gas production system, including the reservoir, wells, and the surface network. So each one of these different tools are used for different modeling properties. So to model our reservoir, we are going to use MBAL, or which we'll be covering today. To model wells, we'll be using Prosper, which we'll be doing next week. And to model our surface network, we'll be using something called GAP, which we'll also be doing next week, right? And all these models would complete our oil and production system. So this website gives you more information on, so for example, if I just go on MBAL, it gives you information on what the software is and the equation used to develop the software. So MBAL uses the material balance equation, which you all would have learned in reservoir modeling. And if you all remember, material balance is used for a non-dimensional reservoir analysis. So last week we would have learned about CMG and 3D building a three-dimensional network. However, today we're just going to be looking at non-dimensional reservoir analysis. And you all could always read more about it here. You could also do history matching on MBAL, where we match historical production to what we simulated, similar to what we did in CMG. We can also model aquifers, which we will be doing today, and forecast production to predict how the reservoir will behave in the future. So you could always read more about it if you want additional information on the PETEX website, right? So going back to today's session, I would have sent you two documents. So one is a Word document, which will be the information we'll be using for today's tutorial. And I also have an Excel file. If I just open it. And this Excel file will contain historical production data for our model. So we have the date that the reservoir was producing, the pressure, the cumulative oil, gas, and water for this system. So we have it from the 1st 2001, and we have prediction up until June 2006. Okay, so to begin our tutorial, an oil reservoir in southeast coast Trinidad has been on production for some years, and we saw from 2001 to 2006. Initial estimates from geological studies indicate a stock tank original oil in place of 186 mm STB. Further investigation will be needed to evaluate this. So based on the geological studies, the original oil in place that we see here is an estimated value, right? So we want to be using MBAL to validate our original oil in place value. So today we're going to learn to create a representative material balance model for the reservoir using and history matching it to our production data. to determine the drive mechanisms, to verify the stock tank original oil in place, and to forecast production in the future. Here we have the data available, which would be fluid properties. So we have our gas-oil ratio, the oil gravity, gas gravity, water salinity, bubble point pressure, temperature, gas-oil ratio, oil formation, volume factor, oil viscosity. We also have our reservoir is also called a tank. So our tank properties would be the pressure at 4,000 psi. The initial temperature of the reservoir is 170 degrees Fahrenheit, 23% porosity, connect water saturation 0.15, no gas cap, original oil in place, estimate 168, right? And again, we have the start of production in 2001, and we have our relative permeability data. So we could start with opening MBAL. So we could go to the start icon, and actually let me wait on Nishkal to come back because I think he went to get someone. So everyone is back. We're going to start MBAL by going to the start, typing MBAL, and click to open our MBAL. So here we see there's a previous project that someone was working on loaded here. So if you have this, just go to File, New. So for MBAL, we always work from right to left, meaning we move from the right to the left and from up to down. So after File, New, we're going to go to Tool, and we'll see that there are many different tools in MBAL. So today we'll be using the material balance, which is used to allow non-dimensional reservoir analysis to be conducted through the life of a field. We also have reservoir allocation, Monte Carlo, which you all will learn in reservoir engineering, is used to a tool for estimating oil and gas in place. We have decline curve analysis. So we use this in classical decline curve analysis tool, where we would use production history is fitted to the curves and are then extrapolated in an attempt to predict future performance. So today we're going to look at material balance, but if you want to learn about the different tools, you could always go to Help, Context, and it will give you an overview of all the different tools. So we see we have material balance here, reservoir allocation, Monte Carlo, and what each one of these are useful for, right? So I'm just going to close this off. That's just a mention. So we're going to tool and material balance. So after this, remember I said we go from right to left, we go to the options tab, and here we would define our reservoir. So our reservoir fluid is, we could choose between oil, gas, retrograde, condensate, and general. So we're gonna leave it on oil. Our tank model, again, remember I said tank is the word we use for reservoir. So if you have a single reservoir or a multiple reservoir, like if there's fractures, or you have a reservoir connected by a fault, we usually use multiple tanks. But for this tutorial, we leave it on single tank. Here you choose the type of pressure, volume, and temperature model you like to use. We're going to leave it as simple. We could choose if we want our production by tank or by well, and in this example, we're gonna leave it by tank. And our compositional model, we could choose if we would like it to be purely compositional, as if we have the composition of our fluid, but we're gonna leave it as none. So far we haven't changed anything. We just described that our reservoir is oil and single tank, and you could always fill out this information of your company, but this is not necessary, right? So we're gonna click done, and we'll see that our reservoir pops up into the middle of our MBAL model here, and it's blank or white because there's nothing in it. So the next thing we want to do is move to our PVT, which is our pressure, volume, temperature, and we're going to click on fluid properties. So here we're going to fill out information that describes our fluid or in our reservoir. So using your tutorial data here, I want you all to fill out this table for your fluid properties. Okay, so everyone seems to have the correct value. So simple plug-in, so 500 for gas oil ratio, oil gravity 39, gas gravity 0.7898, water salinity 10,000, and we have 0% H2S, CO2, and N2. So now that we have placed in the black oil properties for oil, and we also place in our water salinity, and we also indicate that the produced gas will have no CO2, H2S, or N2. We want to match our laboratory data that we have available to the correlations that MBAL has so that we could describe our fluid properly, right? So if you look at this side here, we have different correlations for, if you click the drop down, for bubble point, formation volume factor. We also have different correlations for oil viscosity, right? So based on your fluid composition, you want to choose which correlation best describes your fluid. So what we want to do is go to match on top here, and we'll type in our temperature, which is 250. The bubble point is 2200. And again, we're going to type in 2200 in our pressure, our gas oil ratio of 500, oil formation volume factor of 1.32, and oil viscosity of 0.35. So this data you usually get from your lab reports. And in this example, we only have one, but you can have multiple data points, right? So after this, we're going to click on match again. And we're going to click on calculate. And we'll see that the software will have done some regression, and we see standard deviation parameter 1 and 2. Click on the match parameters, and here we want to see, if we click on help, so this says this screen displays and allow editing of results of PVT matching calculations, right? The regression technique used by the program applies a multiplier, parameter 1, a shift parameter, parameter 2 to the correlation, and the standard deviation displays the overall best match. So that's just let me just close up this now. So that's just saying what parameter 1, 2, and standard deviation is. So what we need to do is to determine for these correlations which one is the best match for our data. So parameter 1 should be close to 1 as possible. Parameter 2 should be close to 0 as possible, and the standard deviation should be the lowest, right? So sometimes you have to look closely to determine which one which correlation best matches our data. And as you could see here, for bubble point solution, gas acceleration, oil formation factor, we have to look at all three to see which one best matches our data. And if we go to the next tab, for oil viscosity, we didn't have data for gas formation, body factor, and gas viscosity, so that's why it's empty, right? So I want you all to look at it and tell me which one best matches our data. So I'll just give you all some time to look at it. Okay, so very good, class. So for the first correlation and the second one, which is oil viscosity, which one? Okay, so very good. So the first one, which is this tab here, the first correlation, we're gonna choose Glasso. It's already on Glasso. And for oil viscosity, we're gonna choose Beggs et al. Because it parameter 1 is as close as 1 as possible, 2 has the closest to 0 and has the lowest standard deviation. So you have to look at all three, right? If we click on plot, now for this example, we won't be able to see it properly, but just to mention. So for example, if we go on our match data and we click, let's look at oil viscosity. So this would be the point or the value that we would have put in for oil viscosity, right? And let's say we compare it to the one above, the ghetto. We click on temperature and we double click on oil viscosity again. But because we only have one point, it's kind of difficult to see, right? Because it kind of superimposes on each other. But when you have more than one data point, you can see how close the graphs would be to each other, right? That's just to mention if you will have more data in the future. So we're gonna close off this. We're gonna click done again, click done again, and we should see use matching be blinking here to indicate that we just matched our data, right? And again, matching means that we would have selected a correlation that best describes our fluid in our reservoir. Make sure you have Glasso and Beggs et al. And click done. And we should save our project. So file, save as, save it in your August software session. And we could save it as PVT match model. PVT match save. So we selected material balance. We would have gone through, that is at oil. We would have placing our fluid properties, and now we're going to go into input tank data. So here we will describe our reservoir. And again, I want you all to use the tutorial and use all the tank parameters and fill out this section. Okay, so get everybody filled it out. You all can see it's pretty simple. So our reservoir temperature 120, our initial pressure 4,000, porosity 23% or 0.23 fraction, tonnage water saturation 0.5. For water compressibility, we're going to use correlation. We don't have a gas cap, so 0. And our estimate from geological surveys of original when it phase was 186 mmSDB. And the start of our production would have been the 1st 2001. So we could click validate to make sure everything is okay. If there was a problem, we would see a pop-up and we could fix it. But in this case, we don't have any errors in our data. And we would see that we have the rest of the tabs showing up. So the tabs that we see red, we need to fill out the information. And again, in MBAL, we work from right to left. So the next one would be our water influx. So for now, we're going to leave it as none. For rock compressibility, so this is if we have data for rock compressibility. However, in this case, we don't. So we're going to leave it as from correlation. Here again, they're asking for rock compaction data. And we don't have any data for our rock compaction, so we're going to move to relative permeability data. Now, those who did CMG last 2 weeks should be familiar with what query functions are. We would have used that for CMG. And our relative permeability data we normally get from experiments, right? So we have water, oil, and gas relative permeability. And those who are doing advanced reservoir and reservoir engineering, again, you all will understand what relative permeability is. Anybody know what relative permeability is? Jamie? You're doing reservoir engineering. What's relative permeability? Okay. So relative permeability is how one fluid would flow in the presence of another fluid, right? So how would water flow when we have oil and gas present? Or how gas will flow when we have oil or water present, right? So again, I want you all to use your data from your tutorial and fill out the relative permeability data. Pretty straightforward. So I'll just fill in mine. And if we click on plot, we should see some relative permeability graphs if you would like to analyze, right? KRO versus SG. So if you click, let me start over in case you all missed that. So we're gonna go on plot. And this would be the relative permeability data that we would have just placed in, right? So those who are doing reservoir engineering, this should make sense to you all. And if it doesn't, come and talk to me after, right? And we could go through it in case you all forgot. So just to remind you, this would be a relative permeability versus saturation graphs. So we're gonna close off this. And the last thing we're gonna put in is our production history. So what I want you all to do is to open the file that I would have sent named oilres1 on Excel and copy paste the data. So select all the data, click copy. Let's go back to MBAL and click on like number 1, right click and click on copy table. Oh, I forgot to click copy and then paste. Yes, thank you. Paste data. Right. So always make sure that your columns are the same when you, so pressure, cumulative oil, cumulative gas, water. Always make sure it's, sorry, wrong tab. It's in the right order and make sure it's in the correct units, right? Whenever you're copy pasting something. If we click on the check gas oil ratio here, our bubble point was 2200 and our reservoir pressure is 4000. So we should be above bubble point. So here, this is why we see a straight line for GR, right? Because we are above bubble point. We're gonna click on validate to make sure everything's okay. We're gonna click on done. And we're gonna save, or probably save as, and rename it to I guess we can name it reservoir data complete and save. So here now you see that your tank is green, and if you put in, I think Nashkal, I saw you was putting in some aquifer there, you might see some blue. Yeah. So the green would indicate oil. If there's gas, you would see red, and if there's water, you would see blue, right? So the next thing we like to do is to make sure our model is accurate. So what we want to do is go to history matching and click on all. And we would see three different tabs coming up. So one is our energy plot, our graphical method, and the last one is our analytical method, right? So let's expand the energy plot. Right. So this energy plot shows us the drive mechanism in our reservoir, or what's causing our production, right? So we see that the main drive mechanisms for this aquifer is fluid expansion and pore volume compression. So again, those who are doing reservoir engineering in the material balance equation, we have different expressions for each one of these. And again, if you don't remember or want to know more, you can always talk to me more about it, right? If you click on help as well, it will give the explanation of what the energy plot is. So the plot shows the relative contribution of the main source of energy in the reservoir and the aquifer system. It does not in itself provide the user with detailed information, but indicates very clearly which parameters and properties should be focused on. Example, PVT, formation compressibility, water influx. For example, if the water influx area is very small, then the aquifer properties could be ignored and you could focus on other areas. Let's minimize this and we're going to look at our Campbell's plot. So here we have what is called a Campbell's plot. And again, let's click on help. And our Campbell's plot is a graphical method that shows us the aquifer impact, right? So I should have, let's see. Okay, so to show all this file that shows the Campbell's plot, and based on the curve, we could tell the strength of the aquifer, right? So if we see a trend similar to what we're seeing on our graph, we know that it's a strong aquifer. Let me just close off this. So we're seeing a curve similar to this. So it could indicate the presence of a strong aquifer. If we see a trend more in this way, we know it's moderate aquifer strength. And if up and down, we know it's weak aquifer. And of course, if we see a straight line, is volumetric depletion, right? So let me just go back to our Campbell's plot. So in this case, because we see this particular trend of the graph, we know that it's likely that there's a strong aquifer presence, right? And previously we would have selected no aquifer. So that's something that we were not sure about, but now based on our Campbell's plot, we know for sure that there's a presence of an aquifer, right? And the labels you're seeing on the graph would be those that you'll use during your material balance equation, right? So I'm going to minimize this again. And this is one of the most important graphs for our purposes in MBAL, which is our tank pressure versus our calculated oil production. So what we see here, the blue line represents what we have simulated, and the black trend shows our actual production data, right? So what we could see is that these two lines are not matched up, so something needs to be adjusted in our model, right? So that our simulated model and our actual production data will match. So again, the black dots would represent the data that we would place into our simulator, which is actual production history, and the blue line shows what we have just created. So we're going to click finish. And what we want to do, because we know there's a possibility of aquifer, we're going to go and ask the geologist now if there's aquifer to give us some aquifer parameters, right? So we go to the geologist. Luckily, we have one in the room. So, and she would normally give us some parameters to use for our aquifer. So again, you could go to our tank. So you could go to input tank data, or you could double click on the tank. And we're going to go to water influx. And we're going to model our aquifer. So in this case, we're going to use Hurst Van Everdingen modified. But based on the data that you have, so let's just click on small plot. We see that we need the aquifer volume. If we click on Carter Tracy, so each different reservoir model will require different information, right? And again, we're going back to Hurst Van Everdingen modified. And again, those who are doing advanced reservoir should know what the different models are used for. Here we have system to describe the type of aquifer we have, if it's radial, linear, or bottom drive aquifer. In this case, it's a radial aquifer, and we place in values for our reservoir thickness, reservoir radius, inner outer radius, encroachment angle, and aquifer permeability to calculate our water influx. So again, I want you all to use your tutorial and fill in this information. Ravi, outside, somebody could open it open, please. Actually, I'll go and open. Again, pretty straightforward. The reservoir thickness was 250 feet. Reservoir radius 2,500 feet in an outer ratio 5. Encroachment angle 180. Aquifer permeability 10 millidarcies. And done. So now we're going back to our history matching all. And we should see an additional graph being shown here. And this graph, if we expand, this is our radial aquifer plot. And this is, if we click on help, again, you could see it explains what this WD function plot is. and its dimensional cumulative water influx versus dimensional time. And again, it shows the typical pressure for aquifer, right? And you all could read more about this graph. But the main focus for us would be our analytical method, where we are matching our historical data to our simulated data. And if we also look at the drive mechanism, we would see that there's fluid. We have water influx being shown here. So before we just had fluid expansion and poor volume compressibility as our drive mechanism, but now we see that our main energy for our drive mechanism is our water influx. Correct. Here we see that what the main drive mechanism would be our water influx. So let's go to our analytical method, which is the main graph we're working with. And here we see, without an aquifer, our simulated results that our software calculated. And we see that with an aquifer, we have a slightly better match to our historical data, right? So here you could see to the side, it shows that the blue represent with aquifer, the red is without. And these points here would be our actual historical production data that we place into the model. So at this point, what we want to do is to use regression to match our simulated model to our historical production for the parameters that we were not sure about, right? So some of the parameters that we weren't certain would have been the original oil in place, the outer inner radius, the encroachment angle, for example. So to do this, we're going to click on regression on the top here. And these would be all the parameters that would affect the calculation of our simulated results, right? So like I said, we want to choose the ones that we were not too sure about, which would have been our oil in place, the outer inner radius. Now the reservoir radius is kind of known, our encroachment angle, and aquifer permeability. Now the porosity would be known when we would have done like co-analysis, and of course our reservoir radius and thickness would have been calculated and known from before, right? So we're gonna click on calculate, and after 100 iterations, what the software did is they found to match our historical production data, we have our oil in place from 168 SDB, we have 268. So we have about 100, actually less than that, but we have more oil than we originally thought. The outer inner radius is smaller than we thought, encroachment angle smaller, and our permeability is larger than we initially thought, right? So what we want to do is place these new values into our model. So we're going to click on accept all fits. We're going to click on done. Here we see that our simulated data, or those calculated by the simulator, matches our historical production, right? So we have what we call a history match. So we're going to click finish. And we're going to save our model. Save as, we can name it history match model. History match, save. Now, if we double click on our tank, we go to our tank parameters, we would have remember that for original oil in place, we would have placed a value of 186, but we see that after we regress and we accept our fits, we have the original oil in place being updated, right? So now we know what our updated oil in place is, as well as data for our inner outer radius, ratio, encroachment angle, our aquifer permeability. We're going to click on done. And now we're going to go to history matching and run a simulation. So we're going to click calculate. You can click OK. And we're going to click on plot. So here we have our history data, and this would have been the values that we would have placed from our Excel. So the date, pressure, cumulative, oil, gas, water. So let's look at our pressure, right? So we're on history and we're going to double click on pressure. So we have our pressure versus date. And then we're going to go to our simulation, and you will see that you will have additional parameters that our software would have calculated. We're going to compare it to our tank pressure. So double click on tank pressure. And what you'll see, because our model is history match, is that our simulated data and our tank pressure are on top of each other, right? So this is why you want to make sure everyone understand that. So we're going to click the X, remove all. Let's look at our oil production. So double click cumulative oil production and look at our simulated cumulative oil production. And again, it should have a match, right? So we're gonna put, and you can see that from here, we can also see additional data such as our aquifer influx, solution gas and reservoir that we didn't have in our Excel spreadsheet. So let's close up here. I just want you all to, on the bottom here, if you scroll across, you can see all the additional data. And we have the dates, and it should be from the first 2001. And if we scroll straight down, it should be to the end of our historical production, right? So the last thing we want to do is forecasting. So forecasting is to see, okay, we have our historical data up till now. We have a model that represents our reservoir. So let's see how this reservoir will perform in the future. So to do this, we're gonna click done. You can save, and we're going to go to production, prediction, and click on prediction setup. Now we're gonna leave it. We can predict based on if we have wells, production profile per well, but in this case we have no wells, so we're gonna leave it as the default. And next week we're gonna learn how to create wells using Prosper. But for now we're gonna leave it on no wells. We could do a prediction if, for example, you have water injection, gas injection, but we're just gonna leave it without any injection, and we're gonna start our prediction from the end of production history. Now here we could also determine if we wanted our prediction to be by how many days, or if we want our prediction to end at the end of production history or a specific date. But we're gonna just leave it as the default and click done. And then we should see the production and constraint start showing up. We're gonna click on that. And here we place any constraints that we want on our well. we see that our prediction will start from the last date that we had in our prediction history in the bottom here. And I want you all to click on copy. You see this pop-up, click yes. And what the simulator has done here is the prediction that we would have run before for our simulator is shown here, right? We're going to click on validate and click done. For the next step will be our reporting schedule under production prediction. And here we could define if we want it by year, month, per day. So let's click on year and let's say 1. So we want it for every year. Or you could also leave it on automatic. It depends on you. But let's just put it on here. Click done. And we're gonna click on run prediction. So here we'll see our prediction screen and we're gonna click on calculate. So at a point, the simulator will say oil saturation is less than residual oil saturation, and they wish to continue. We're gonna click no. And here we would see that our reservoir would have continued production from 2006, and if we scroll straight down till 2076, right? At an oil rate of 800 stock tank barrels per day, which you all could always change, right? And we would see that the pressure would have declined from 2000 psi, well, 2407 to, and if we scroll down to 1208, and again, you could see additional parameters if you scroll across, right? So let's click on the plot to see these things better. And let's look at our history. If we look at tank pressure, and then we go to our prediction and we click tank pressure, we could see after the end of our production history how our reservoir will behave in terms of pressure, right? And you can look at, let's remove all. Again, you can look at cumulative oil production. So this would, if we look at history, cumulative oil production, and this little piece here would represent our historical data, and we could see at the end our production data, right? And you all could always look at other predictions. We have an average oil rate of 8,000, which is set. So whichever factor you want to look at, you could always plot it. So we know that this model could run until 2076, the 5th month, if we have an oil rate of 8,000 psi, right? Any questions? Surrender, you understand everything? Pretty straightforward, right? Yeah. Well, the oil rate was set at a specific 8,000 SDV per day. It was set to that value. Yeah, in reality. Well, that's it for today for MBAL. I'm going to stop share and those. So we finished kind of early, so I want those who then finish their CMG to finish it and to practice some software, right? So I just and those who reach late could do this tutorial. So just end the recording and you all could do your practice on your own.